students, today we are going to talk on a new topic, that is on ternary 4-phase equilibria. So far we have discussed 2-phase and 3-phase equilibria. Now we are going to talk about 4-phase equilibria, and after I complete this, I am going to discuss specific cases like stainless steel, superalloys, high speed steel, or even some ceramic systems. So, the next 4-5 lectures we are going to discuss about this 4-phase equilibrium. As you know, in a ternary system, maximum 4 phases can coexist. Why it is so? Because we know that according to Gibbs phase rule, there are F, which is the degrees of freedom, is equal to C minus P plus 1 for a system where pressure is constant. So, if you calculate number of components to be 3 in a ternary system, so for F equal to 0 it will be 4, the number of phases will be 4. So, maximum number of phases which can coexist at a particular in a ternary system is 4, correct. So, that means what? Either one of the phases will transform into 3 phases, or 3 phases will react to form 1 phase, or 2 phases will react to form 2 phases. That means, it is basically transformation of some phases or interaction of the some phases, where total number of phases will be equal to 4. So, that is what we are going to discuss. Now, obviously, there are 3 specific cases which deserves attention. The first specific case is what is known as, I discussed in the last class, let me just write down. The first specific case is the type 1. Type 1 4-phase equilibria is ternary, true ternary, or let me write down the reaction first. Liquid going to alpha plus beta plus gamma, where alpha, beta, gamma solid phases. This is the true ternary eutectic. Why it is true ternary eutectic? Very simple. We have seen in the 3-phase equilibria, you can also have a ternary eutectic involving 3 phases, like liquid going to alpha plus beta, correct. So, we have seen different cases. Even in last class also I have discussed a case in which 2 binaries of the 3 component system, or 3 out of 3, 2 binaries will have isomorphous and one of the binary will have a eutectic system. This will also lead to eutectic phase in the ternary triangle itself, composition corresponding to ternary. So, that is not a true ternary eutectic, those are binary eutectic extended to ternary, but here this one is a true ternary eutectic. Type 2 is written like this, liquid plus alpha going to beta plus gamma. This is known as quasi peritectic. Why it is known as quasi peritectic? This is can be a eutectic, alpha liquid plus liquid going to beta plus gamma, or it can be peritectic, liquid plus alpha going to beta. This is sometimes known as reaction which is neither peritectic nor eutectic, that is why we call as a quasi peritectic. A third type is basically perfectly peritectic, it is a ternary peritectic, or rather we can write down ternary peritectic. So, basically there are 3 different types of 4-phase equilibria possible in a ternary system. 1, true ternary eutectic, type 2 quasi peritectic, type 3 ternary peritectic. For the sake of this course, I am going to discuss mostly on these ternary eutectic, because that is observed and that found many systems, but I will not discuss in detail of these 2, but that I will inform in one of the lectures how the phase diagram will change, correct. So, now let me just tell you that 4-phase equilibria in a ternary system involves basically is an invariant equilibria, right. Why it is invariant equilibria? Is mainly because it involves 4 phases, the F equal to 0, right. So, invariant equilibria means temperature and the compositions of all the phases. Composition of all the phases means composition of solid, composition of liquid phases, all are fixed. So, that means what? In a particular temperature, you will have a you will have a picture, all the 4 phases will exist on a horizontal plane, correct. I will draw it and show you later on. All the 4 phases will exist on horizontal plane, whether it is a ternary eutectic or quasi-peritectic or peritectic, does not matter. In all these cases, because it is a invariant system, all the 4 phases will exist on a horizontal plane at a temperature. Phase composition and all this, the 4 phase composition will be given fixed at each of the points on this 4 phase plane, correct. So, let us now discuss about this first case, which I told you I will discuss in detail. First one is ternary eutectic systems. Now, I'll show you some pictures or slides where try to make sure that you concentrate properly and understand the 3-dimensional shapes of different regions. As we have been doing for the last few lectures, a ternary 4-phase eutectic 4-phase equilibria in case of type 1 involves all the binaries will have eutectics, like AB binary is a eutectic TE1, BC binary is a eutectic TE2, CA binary is a eutectic TE3, and here you see A has lower melting temperature than B, or B has the higher melting temperature. Okay. This is what is the system. So, you have eutectic between AB, BC and CA, right, you can see here. So, what will happen if these 3 things are mixed together? What will happen to the ternary phase diagram? That is what is the purpose of discussion in the class, correct. Basically, obviously, the few things which come to your mind is that you will understand that because there are 3 eutectics exist in the 3 binaries, there must be a ternary eutectic existing, correct. So, if I represent this is as a E1, E2, E3, these points, there will be ternary eutectic E, whose melting temperature will be even lower than the individual binary eutectics. Let us see that, correct. Well, you see here very clearly, I am going to draw it also. You see here that AB has a eutectic, okay. Here AB has a eutectic given by this point, and this eutectic as having terminal solutions alpha and beta on the both sides. AC has a eutectic between alpha and gamma, terminal solution being alpha and gamma. So, this is the eutectic, and CB or BC has a eutectic between gamma and beta. Because of that, you have a ternary eutectic point coming down, this actually surface is coming down and meeting at ternary eutectic point E, okay. That is what is represented here. Things will be clear much here, yeah. This is a very good picture. So, you can see here this is the binary eutectic between BA, binary eutectic between AC, binary eutectic between CA. A ternary one is basically curving down, they are curving down here, correct. So, if I draw a horizontal plane at the ternary temperature, the 3 points will be the ternary, is the 4-phase equilibrium plane, correct. So, be sure about it, these are the liquidous surfaces 1, 2, 3, correct, they are going down, correct. This is the way it is going, this is going, it is going like that and going down. So, if I take a projection of those surfaces, it will look like this, correct. You see here this is a surface projected surface, and there is a ternary eutectic point. It must be like this. Obviously, other than that, there will be other things coming into picture, which is not shown here. So, if I remove all the shades, this is how it will look like. These things will be looking like this if I remove. This is the eutectic here, eutectic there in the binary, and to get the ternary we connect these 3 points like this 1, 2 and 3. So, that means what 3 valleys actually coming down and meeting at point TE. So, now if I drop, I can actually, I will show you how I can draw this triangle on the ternary equilibrium. Okay. Now, first look at the liquidous surface. Okay, this is the liquidous surface coming into down. Okay, this is the one, this is the one, correct. Now, second thing is this is these. What are the primary phase fields? I think this is alpha, yeah, between AB. So, this looks like this if I draw it correctly. This is how it will look like, this is alpha. So, all these other surfaces also look like same. You can see here alpha, beta and gamma. This is alpha, beta, gamma. Gamma is a little bit different, but it is not different, it will slightly distorted. So, if I draw it correctly, this is like this. So, gamma will be exactly like that and beta will be also similar. So, these are 3 dimensional steps. Now, if you want to look at the plane containing alpha and beta, okay, phases, that is how it will look. This is like a asbestos shade coming down in a house, you can clearly see that. This is exactly the same. Similarly, this is between AC, AB, AC, CA. CA is much more clearer. This has there are distortion on the surface also. It is not exactly a flat on the top surface. Correct. Now, if I remove everything, how does it look like? It look like this. There are 3 points E, H and K corresponding to 3 eutectics, and this is what N, M and O with a Z at the center, not at the center, the eutectic tangent point. That is what is I am saying the ternary 4 page plane. So, if I draw it properly, N, M, O and Z, correct. That is what you have seen. So, each of these points, this will tell you the composition of beta, alpha and gamma, and this is the eutectic. So, one can actually join this will form a tetrahedron. Many times this picture you will see in the books. So, it looks like that liquid is dissociating into 3 phases, compositions are given by N, M and N, M, N and O, correct. That is how it looks like. How do I get the N, M and N? N point is obtained from these 2 ends. This is the one binary, this is another binary terminal solution. If you connect it here, M is also similar, O is also similar. Correct. Now, below that, below this surface, below this, in fact, it is already drawn. This is what is alpha, beta, gamma surface, alpha plus beta plus gamma, correct, 3 phase surface. So, it looks like this and this. This is how it will look like. So, this is the alpha plus beta plus gamma surface. Okay, I think I should go back to the board and draw it and show you now, otherwise it will not be clear to you. And while doing that, I am going to use some color chalks. Okay. So, first thing I draw is this triangle. Oops, this is getting distorted. Better to draw in this way. So, first eutectic is between A and B. fine. Second eutectic is between B and C, sorry, A and C. Again, this is going to come down. Like this, and third one between B and C will be little different. Okay, let us see how I can draw it. Correct. So, that is how it will look like. Now, you can join these 3 points by yellow color chalk. This is E1, E2, E3, E. In fact, it should cut it down much further, then it will look nice. That is how it will look like. And now, to get this A, B, C points which is sitting on this, I can join these two. Similarly, I can join these and these, and I can join these and these. So, these triangles is, actually speaking, this E should fall on that. E should sit on that. That means E will be much further down. So, this is what is the ternary space model. So, now if I take a projection on that, it will be little distorted. These are the 3 single phase zones. These are the 3, so alpha, beta and gamma. This will be alpha plus gamma, beta plus gamma. Let us not write it, it will be complex. This, it will look like clumsy, only show by points or the lines. And now, we can draw these projections. And finally, I can draw 3 eutectic meeting at a point E1, E2, E3, E. So, if I project everything, this will look like this. These are the 2 phase region, this is a liquid region, this is basically beta plus gamma, this is beta plus gamma plus liquid, alpha plus beta plus alpha plus gamma plus liquid, and this is the 3 phase region. Okay. So, one can actually draw this triangle to show the 3 points and also eutectic very clearly. This is exactly we wanted to, I just wanted to show you, so that you can draw yourself. You should try it and draw yourself. Now, what we are discussing now in this further, what we will do is as follows. We are going to take the isothermal sections and the vertical sections and show you how things will change. This is really important, because if you understand until you draw it, you won't able to appreciate how things happens. Okay. So, before that, let me just tell you that let me just draw this liquidous surface. Yes, that is very important, which I have not drawn it. So, I will draw it at the top and show you So, let us suppose here actually I have to remove little bit this. Okay. So, so you can set this this is what is that liquid surface looks like. This is the eutectic point, these are the binary eutectic point E1, E2, E3, right. Okay, so I think you should try and drawing yourself, so that you will understand much better way. In the next lecture, I am going to talk about these projections and also little bit about solidification, how it is happening.